Okay, so today's daily challenge is minimum distance between BST nodes. So basically, we want to find in BST, we want to find minimum distance between the values of any two different nodes in the tree. So basically, if we want to find, let's say, the tree looks something like this. Because this is binary search tree, it has to follow these rules here. Okay, let's say, in this case, basically, the minimum difference is 89 and 90. So it's gonna be 1. So if we want to find this, basically the basic idea here is that if we do DFS on in order traverser here, so basically it's gonna visit 21st because it's in order DFS. It's gonna visit the node itself second, and then visit the last node third. So doing in order GFS will basically give us ordered list of nodes, right? So let's see if we can build up this kind of array where you store ordered list, then you can only compare the number right next to you. So you can, if you are starting from 20, you can compare with the 40, or if you are starting in index 1, you can keep updating the minimum, right? So initially 40 minus 20 is 20, but then there's 89 minus 40, 49. So this is not minimum, but there's 90 minus 89, which is 1. So it's gonna update this minimum to 1. So this is gonna be the answer. Okay. So this the time complexity will be of, let's say, of n, because we are pretty much visiting every single node. So time will be of n, but also there's a space complexity of n as well, because we are utilizing this array to store n number of nodes. Maybe we can do better with the space complexity. We cannot really be better than of n. If we want to do better than of n, it's gonna be somewhere around like either of log n or of 1. But of 1 doesn't really make sense because you have to compare at least each node. So log n, same reasoning. You cannot really get the difference just by visiting certain number of nodes. So you have to visit every single node. So I think time complexity of n is the best we can get. Maybe we don't need this array if we basically store the previous value, because here when we iterate from here to here, we are just basically keeping track of what number the previous one was, which is 20, and then comparing that with the current number, which is 40. So if we can keep track of like previous node somehow in this in order traverser, then we should be able to calculate. So the logic will be in our DFS logic. So DFS on the left node. Okay, and then we need to calculate the difference of the current node. That's what's in order traverser is doing. So basically we are using this current and then basically comparing whatever we got from the left. So basically this left should return 20. And then as a previous node. So at some point we have to set previous node to be current node so that when we return back to the parent, they can actually use previous node as the left node or left node as a previous node. And then here the previous node can be empty if you're visiting for the first time on the leftmost child. So we need to check for if previous node is there. Then calculate the difference. So a previous node will always be less than the current node. So min will be the minimum of previous node and then the current node. Okay. And then lastly, we need to do the same for the right. So what's going to happen to the right node is once this finishes, the 40 will be set as previous node, and then we're going to visit the right node. So it's going to try to subtract, and then it's going to, if it has left node, it's going to visit left node. If it doesn't, then it's going to use this 40 to calculate the difference between 89 and 40. And then visit right, doesn't have right, so it's going to return. So previous parent will just return, and then 90 will now, so this returns 40 as a previous node. So 90 will now be the current node. So 90 minus 40 will be calculated. Okay. Yeah, so once this is all done, we can simply return the min value. Okay, so let's try coding this up. Okay, so let's bring up keyboard. Okay, so in here, actually I'm gonna bring my good note over here. So my DFS logic will be def DFS. Now I need to be receiving the node itself. Okay. And then we first need to check if a node is not null. null. If it's null, we just return because there is nothing to do. Okay. Otherwise, what we're gonna do is this DFS logic. So we're gonna call DFS on the left node. And then checking if there is a previous node. In that case, we didn't define the min value here. So min diff will be okay, min diff will be currently, I'm gonna set it to max for now because it will eventually be set to some number. Okay, so min diff, and then when previous node is there, we're going to calculate the min diff. So it's going to be min of min diff, and then what else? The actual calculation. So node dot var minus prev node dot var. Okay, so this is going to be the min diff. Once we're done, we need to set previous node to be the node itself, and then do the same on the right tree. So once this is all done, we can just simply return min diff. Okay, let's see. So we're checking for null node. Is there going to be any empty tree? No, there will always be at least 2 nodes. So this is good. Okay, so min diff, I might actually declare non-local here because it's not a reference. So there's a node, the previous node is initially null, so I'm actually going to declare it as none as well. I think because previous none is none, previous node is none, I might need to do the non-local as well. Okay, so let's try to run it. Wait, how do I hide keyboard? Okay, running. So env is not value for the expected return type integer. So they are expecting integer. Oh, it's because we are not actually running. So I didn't call DFS on the root node. So that's why. Okay, let's see. Okay, so running case 1 and 2 works. If we submit, yep,